So we're going to look back at the table we had, which had surveyed people about if they had a household member that smokes, and if that person had asthma. And we're going to start to look at conditional probability on this table. So as we go through, the first question says, what is the probability that a randomly selected student has asthma? So this is just a basic probability. Well, we already have our letters in, so this is P of A. And we know for P of A, we have to go all the way to the end to find a total for A, and put that over 938. Now, as we start to do conditional probabilities, the real kind of reason we do that is because we start to do comparisons of things. It says, while someone might wonder what the probability is that a randomly selected student has asthma, they also might wonder what the probability would be if we only look at students who live with a smoker. So in order to compare these numbers with these large fractions, I don't have a great idea what the actual value is. We're going to start to type these in and get the answers to the nearest number. So this equals 0.20 if I type that in. So the next question, we're going to start to make some of those comparisons. What is the probability that a randomly selected student has asthma, given that there is at least one household member who smokes? So when we say that given, it means we are only looking at numbers in that column for the person that smokes. The way we would write it, what's the probability the student has asthma, given that we know that there's a smoker in the house. So we can't use the 938. Our total number in that column is 935. And the A number in that column is 113. So when I type this in, I end up getting 0.29. So right now we can see that if we just looked at the people who had a household member that smokes, there's actually, we talked about chance, there's a 9% greater chance that they would have asthma. So another group we might look at says, what is the probability that a randomly selected student has asthma, given that there is no household member that smokes? So now we want to know the probability of A, given no household member that smokes, so as complement or as prime. So now we're just looking in this column. So looking for my two numbers, my total has to be 543, and the number in the A column is 72. So we have 72 out of 543, which ends up being 0.13. So only, if we talk about chance, only a 13% chance if there are no household members that smoke that a person has asthma. So no, conditional probability helps us find more accurate probabilities for specific groups, but it does not imply causation. So we kind of know from other things that being around smoke does cause asthma, but that's more other types of studies. But you can start to explore and see if there's correlations or patterns in different things using conditional probability. We're going to head over to our general table that we did in the last lesson and fill in each of these because there's actually a formula for conditional probability. So we know we see our 1 down here, which means this is the probability table where it's just straight numbers. So as we fill in the probabilities in my totals column, right, these are just the probability of A or B or not A or not B. And then all of our other probabilities in the middle are probabilities of intersections where those two things cross over. Now, if you think about it, as I write these, the order doesn't really matter. So I could write probability of A and B, or I could write probability of B and N. And that will be something we'll talk about in a second. So we can say that the probability of the intersection of two events is commutative, right, where we can change the order. So we're going to start to look at conditional probability, and if we just were given values, like a couple different probabilities, how would we calculate it? So if I say the probability of A given B, it means I'm only looking in the B column. My total, the number I put on the bottom, would be P of B, because that's the total in this, row, not column. And the number I would use for A would be this one. So the conditional probability formula can be found by dividing the probability of A and B by just the probability of B. So we're going to look at a second one, probability of B given A. So now A is my given, so I'm just in the A column. So my total is P of A. And my numerator, again, because that's where the B number is now, because we're finding the probability of B, is probability of A and B. So we see that conditional probability is not negative. These two fractions are not equal to each other. They have the same numerator, but different denominators. So on the next page, we'll start to look at how to use this conditional probability formula when we don't have the information in a two-way table.